Hi there and welcome to part 2 of the video series on how to build MYRO. In this episode you will see step by step how MYRO's hoverboard is put together. The hoverboard can drive around autonomously like a robot vacuum cleaner, but can also be controlled via Bluetooth. The hoverboard is a modular design which fits together like a puzzle, just like every other part of MYRO. Because of this, there is almost no need for support during printing, and so post-processing of your prints is not necessary. For this video I used the hoverboard of MYRO prototype number 2. I had printed this board with a 0.8mm nozzle at a speed of almost 100mm per second. That's why the hoverboard looks kind of rough. Most of the components are mounted on this plate. I've made a custom PCB which hold the HC06 Bluetooth module and a few different JST connectors so the servos and sensors can easily be connected and disconnected. The hoverboard is controlled by a Arduino Uno and it uses a LN298H bridge for driving the motors. First, let's put in the rotating ultrasonic obstacle avoidance sensors you may have seen in part 1. If you have not seen the video yet, make sure you'll check it out to see how these are put together. The sensors slide in from the front. They rotate around an axis. For this axis I used a 60mm long nail which has a diameter of 3.5mm. I am using nails for this because they are not only cheap but also because they are widely available. The servo brackets are held into place by two 3.5 by 16mm screws. If you want to make the connection stronger you can also add a little bit of hot glue. For the wheels of the hoverboard I used the wheels of an old pram I had lying around. That's why I had to make two adapters for the transition from the pram wheels to the motors. With the latest design of MYRO, that is no longer necessary thanks to patron Sean. He has redesigned the wheels so that they can easily be printed. PLA rims and TPU wheels. That is why an adapter is no longer needed in the latest design. This adapter is secured to the motor shaft with M4 by 6mm Allen set screws. The adapter is then attached to the wheel with 3.5 by 16mm screws. But before we do that, let's print and assemble the rear light cover. The cover is printed with white PLA and has 4 spacers on which a ring with 16 LEDs is mounted. To hold the LED ring into place I cut 4 tiny nails to length and heated them up with a torch just enough so they would meld into the PLA. You can also just use a lighter, it will work fine as well. Don't heat the nails up red hot. Heat them up so they will melt through the PLA but not destroy the rear light cover. Now this is done, let's see how it will look. As you can see this looks pretty good. Now let's put the rear light on the hoverboard. The JST connector goes through the hole and then the cover just snaps into place. For the third little wheel in the back, turn the hoverboard upside down. Align the hole in the spacer with the hole in the hoverboard and screw it into place with two 3.5 by 35mm screws. Push the rubber adapter in that comes with the wheel and after that is done, do the same with the wheel. When all of this is done, make sure the wheel moves freely in all directions before you continue. Now, let's attach the motors with the wheels to the hoverboard. They should just slide into place. When all the wheels, motors and sensors are attached to the hoverboard, it is time to insert the plate which holds most of the electrical components. It slides in from the top and is held into place by two 3.5 by 25mm screws. Time for a quick ad, because this video is sponsored by Tinytronics. They offer a wide range of mechanical and electrical components as well as 3D printer filament for a tiny price. So if you are looking for new components for your project, make sure you check out their website. Now all of the electrical components are in place, it is time to plug everything in. Thanks to the soldered-on JST connectors, this is a piece of cake. After you have connected all the electronics to the microcontroller, it is time to put in the battery. MYRO's hoverboard holds a 12-volt DC closed lead-acid battery with 7 amps of power, which can eventually be charged through a charge port in MYRO's backpack. And finally, it is time to glue the two pieces of the cover plate together. First, they should just snap into place. Then, add a little bit of glue between the two touching surfaces. Put the cover plate on top of the hoverboard and screw it into place. Remember that the cover plate will eventually be the transition plate between MYRO himself and the hoverboard. All that is left to do now is upload the code to the microcontroller and see if it drives. I hope you enjoyed this video. The entire project is available on Patreon. I have put a link in the description below. Also, don't forget to subscribe because there is a lot more to come.